pipelines. Pipelines are a lot of things. They're politically a hot topic, which is interesting because they are really a very safe, efficient way to move things. Everything has its challenges, but just like a pipeline that's under the ground for like moving natural gas or gasoline is a very safe and efficient way to move things. In machine learning, we want to develop pipelines that are efficient ways to do code, right? Every time that we put something together and kind of sequentially applying a list of transformations, kind of followed by a final estimator on a data set, pipelines allow for the integration of kind of multiple processing steps in sklearn. We're going to use pipelines in sklearn to be able to, for us to bundle all of this. So we don't have to, we want to build one model that we can run, right? And so far we've done some pre-processing, and then a couple lines below we build a model and then we train the model. But we want to be able to kind of wrap that all up into one object and take advantage of the very smart people who've come before us and figured out ways to kind of optimize the flow of those objects. And so that's what a pipeline is. And here's a cool picture of a pipeline. And so you can now find jobs kind of called machine learning engineers, right? Which I find to be super fascinating. And it's typically kind of a software engineer, and their job is to make the machine learning models work, right? So you might have a few people who want to be or get a title of computer scientist or engineering machine learning scientist, but there'll be a lot more jobs actually related to the engineering aspect of that, and that's actually making it work. And your job is not really to pick through the data at individual times and find the best hyperparameters. Your job is to make a pipeline that is very stable, that will function for all of the data set you put in. So here we might have the very first is data preparation, so like data collection, cleaning, and maybe augmentation, right? Maybe that's data coming in from other spots. Maybe you're also just running some physics-based models and adding the physics-based models to the data set because you have 100 experimental data sets, 50 physics-based models, and you say, well, my physics-based model is just adding some first-order knowledge to the system. And then model engineering, I've got feature selection, feature extraction, and feature construction. And again, that's what data exploration is. So when you think about your projects that you're working on, if you want to do some data exploration, I really would like to see, you really should just do an exploratory plot of features and see what kind of pops up and what's interesting. But a pipeline would kind of automate this, kind of all go into your features, right? You don't want to be individually looking through data sets the rest of your life for features. The goal here is to create a pipeline that can automatically do that. Model generation, you have your search space and kind of optimization methods. So maybe we're doing some like support vector machines or k-nearest neighbors or deep neural networks. And so you're just kind of building out your model, and then you're going to run some optimization, right? So what we just talked about, hyperparameter optimization. And that's why it's important if you have a data set that's doing this or a pipeline that's doing this automatically to maybe have some validation and some testing data, because you're just going to hit play on the pipeline. It's going to cycle back through a bunch of times on your data set. Architecture optimization, maybe you want to run it on a GPU, maybe you want to spend more money and get the next server up on AWS, right? So it's like, how much money do you want to spend on where you're running this? And then model evaluation, right? Kind of low fidelity, early stopping. We'll talk about that later. Kind of surrogate models, weight sharing. We haven't really talked about those at all. But basically, you can imagine that your pipeline, you start it, it creates some features, it runs the model, and then it gives you some results and some metrics, because we need to know how well your model performed. And again, if you're doing hyperparameter optimization, which kind of loops back to this. And running this through over and over and over, by the time your model comes out the side, your test data has been complete. The knowledge in your test data has been completely integrated into your system, which isn't really what you want. So